Yes. So yes, in the previous class we had seen about the transformations, that is especially with 2D transformations, and only its basic transformations like translation, rotation, and scaling. So today we'll see about a few more other transformations. Okay, so the other transformations are what? So these are also transformations where there are certain changes made to the object or to the model that is displayed onto the screen, right? But these are not so much in general use, whereas moving an object, rotating an object is a common feature that we do it very frequently. So there are the other transformations are the options that we generally use a little bit in rarely, sometimes whenever it is required, not in all places, every time it is not necessary. So one of them is reflection. So reflection is nothing but we want this uh, we want the object to be mirrored or to be copied onto the other side or to the opposite side. So between these two sides there must be a dividing line or a plane. So since it is a 2D transformation over here, it has to be only a line. Okay, so it has, so that it the object is being copied onto the other side. Okay, so reflection, so basically we have in this particular figure over here, we have this object which is placed in the first quadrant in the x and y axis, but now we want to have a reflection or copy of this. So in solid edge or even in other modeling software also, we have this option called copy, right? So copy means, what does it do? It copies the object that we select and it places onto the other side wherever we draw the mirroring line, right? So here let us take let the reflection to be about its x-axis. So we want the same object, same size, to be copied onto the other side of this x-axis. So the other side for this x-axis is only this below portion. So if we take this as first quadrant, second quadrant, third quadrant, and fourth quadrant, this object now has to be copied only onto the fourth quadrant or to the other side of the x-axis. So at the same exact distance from x and y. So it has to be placed exactly like this only when we copy around this about its x-axis, right? So how does this happen? So if let us take that the object has got the uh, coordinates of x comma y, and after reflection here it is going to be x dash comma y dash. So what is the values of x dash and y dash is what we should get, so that the object is being reflected and we get the copy onto the other side of the x-axis. So after reflection, what happens? So as I said previously, it is at a distance of about x value. Okay, so from here it is at a distance of x, right? So here after reflection also it should be to the same distance only. So this x value is not going to change even after reflection. So that is why x dash is going to be same as x value after reflection also. But now the next thing is about the y dash value. How to get the y dash value? Since it is going to be mirrored about the x axis. Okay, here what is happening? X is going to be a positive value and y is going to be negative value because it is the fourth quadrant. So whatever is this y axis distance, the distance over here before reflection, okay, right? So that has to be also be to be maintained at the same distance only over here, but the value will be same but with a negative sign, right? So thereby what will happen? Y dash will be equal to negative minus sign of y. Okay, negative value of the y value only. So because here it is going to be about its x-axis, reflection about its x-axis. So if you put it in matrix form, it will be x dash y dash will be equal to xy, x and y. In the next matrix it will be 1 0 and 0 minus 1. So we get that x plus, sorry, x for x dash will be x value and for y dash it will be minus 1. So in general we can write it as p dash is equal to P into Rx. It's better that we write about over here with respect to what axis it has to be reflected. Okay, right? So this is about the reflection. So similarly, we have about the y-axis also. If we do the changes with respect to y-axis, so I have previously the object over here. Now it has to be reflected back about its y-axis. That means which is now in the first quadrant, the object should have a copy in its second quadrant. So in this case, logic is same, but the values are a little bit different. So initial point is x comma y coordinates. Finally, after reflection, it is going to be x dash comma y dash. So here in reflection, what is going to happen? Previously, it is at a value of x and y, right? So now what happens? X dash value will be, this value will be minus x, because here after this point, since this is the reflection line about which it has to be reflected, the object has to be reflected, from here onwards it is going to be negative x-axis minus x value, right? So thereby that is going to be the change. Height should be the same, so y dash will be same as y value only, right? So now we put it up in the matrix form. X dash y dash will be equal to xy. Next matrix minus 1, because x has to be minus over here, 0 and 0 minus 1. So here it will be put it up as p dash is equal to p into ry, because it is going to be rotated about the y axis. Yeah. So next. So similarly, we have it for z axis also. I have not done that. Okay. So next we'll see about what about reflection about its origin. So what happens if we do the reflection about its origin? So initially here it is in the first quadrant having a value of x comma y. Okay, now I'll just tell it that it has to be reflected about its origin. So finally it has to be onto the opposite side over here. So on about its origin means onto the opposite side. So there is no axis that is to be mentioned over here. So exactly opposite to this, right? So the new value will be over here, it will be for p dash will be x dash comma y dash value. On reflection, what is going to happen? So here, since it is going to be shifted from first quadrant to, copied from first quadrant to third quadrant, here both x axis and y axis both are negative. So x dash should have a value of minus 1, okay, and y dash should have a value of minus 1, because both of them are in negative. So when you put it in the matrix form, x dash y dash will be equal to xy into um, its negative value. So the next matrix will be minus 1, so that we get ultimately when we multiply minus x, so x dash will be equal to minus x and y dash will be equal to minus y. So this will be about p dash will be equal to p into ro, because rotation about its origin. So other type of transformation uh, is the shear transformation. So one is reflection, the other one is shear transformation. So what is this shear transformation? Is that uh, there is going to be a change in the shape of the object. Dimensions may not change, okay, dimensions will not change, object shape will change. So previously if we look over here, this is the shape of the object, either a square or a rectangle, but once when we do shearing operation, the shape, that is the length of this line, is not going to change, but the shape is going to change. So what was over here previously like a square, it has now become, after shearing operation, it has become into a trapezium shape. Okay, right? So it is going to change the shape of the object. So here, since it is two-dimensional, here we have once again x. We can share it along x direction, y and xy. Both is also possible in this case. So there are three types. One is along x, along y, and along x and y. Okay. So let us see each one of them one by one. So let us take up as usual initial value of the coordinate. uh, P is x comma y, okay, and after sharing operation it is going to be x dash comma y dash. So we are going to shear it along x only. That means changes should happen only in the x values, but not in the y values. Okay, right? So x dash. So what is going to happen? We are going to shift these points, okay, which is going to have a different x value. Okay, but y value will remain the same. The height should remain the same only. But whatever is over here, these 2 points should be shifted. Say for example, it will be shifted from here to here. So there will be a shift in the x values so that it becomes like this, right? So there's only a shift in the x axis. Okay, right? So that is why it is shearing in x axis. Okay, so what is going to happen? So initial value of x plus whatever is the shearing value along x value into the y, because it has to be shifted to a new y value. So there will be a y value coming into picture. So this value is what we should know, or it should be given, right? So similarly, as usual, we have three things. One is the new value, then the original value, and what is the sharing value. Out of these three terms, any two should be known so that the third one can be found out. Now coming to y dash, if we look over here, there is not going to be any change in its y value itself. The height is going to be the same. So y dash will be same as y only. So putting it in matrix form, it will be as x dash y dash will be equal to xy into 1 by shear of x, and the other one will be 0 and 1. Okay. So this is how there's a change in the shape in when we do shearing transformation. So yes, similarly with y, when we shear it along the y axis also, what will happen? So there will be change only in the y axis. So in the y axis, so that the points will, the coordinates of the point which carries the y value will change, not the x values. Okay, so that's how. So what was previously, the initially it was like this. Now it is going to shear up only in the y direction, right? So it is going to become transformed into shape like this. This is also a trapezium only, but there's a shift only along the y direction only, right? Okay. So that is how this comes into picture. So here again, if we consider initial values, coordinates x and y, final coordinates x dash y dash. So there's a shift only in the y values. So y dash will be equal to y plus shearing value in y direction into its x value, right? So that is what will be. Whereas x dash will be only as x only, the original value of the x itself. So there is not, this point is not going to shift anywhere, this side or this side, but only in the y direction. Right? So xy shearing along both axes. So here what is going to happen if we look at this? Initially the shape is like this, either a square or rectangle. So all these points are going to have been changed after shearing, okay, where its coordinates will change in both x as well as y. Both values will change. So what will happen? This point will get shifted in x as well as in y. So maybe here. So this may get extended over here, and this may get extended over here. So there's a once when you change this point from here to here, there's a change in x value as well as y value, x value and y value for this point, and similarly. Now if we rejoin this, so this is the final shape after shearing that we can see over here. So we can see that this value is different when compared to its original position, right? So thereby both x and y coordinate values will change. So initial coordinate, let us assume x comma y. Finally, it has been changed to x dash comma y dash. Okay. Now x dash value, if we take, it will be equal to x plus shearing value in x direction into its y value. And similarly, there, since it is going to be sheared along the other axis also, y dash will be equal to y plus shearing value along its y multiplied by x. So once when you put it in the matrix form, x dash y dash will be equal to xy. The other matrix 1 into shearing of x, shearing of y, and 1. Okay, this is actually 1. Okay. Yes. So these are all the generally used transformations in 2D transformations. So next one we'll see about the 3D transformation. So modeling is not just restricted to the 2D environment. 3D environment is also there where we consider all the three axes x, y, and z. Okay. So coming to this, the same types of headings like translation, rotation, reflection are also there in 3D environment also, or 3D transformations. So let us go into the same order as we have done it for the 2D transformation. So let us look about how about the transformations in 3D environment. So the first thing is translation. Okay, so here we will have for every point we will have an x value for every point, y value, and a z value. Okay, right? If this is the x-axis, and this is the y-axis, and this is the z-axis. So initial point will be x comma y comma z, and final value after it has to be moved, translation, right? So x dash, y dash, z dash, right? Okay, so translation values we should know. So in 2D environment we had only tx and ty. Here it will be tx, ty, and tz because all the three axes. So every point has three coordinates. Sorry, it has been given with respect to the three axes. So even if we remember doing things on the answers also, we will give the coordinates for every point. Let it be a beam problem or a bar problem or anything, we will give the coordinates. So it will generally ask with x, y, and z axis values. So translation along x axis, y axis, and z axis. So x dash over here will be equal to x plus tx because the point has to be shifted from its original point to an incremental value along x axis. Similarly with y, y dash will be equal to y plus ty, and similarly with z. And once when we put it in matrix form, it will be x dash, y dash, z dash, and we'll get one value called 1 over here, which should be a neutral value. So x, which will be equal to x, y, z, and 1 multiplied by this another matrix. Okay, so that we get the same equations. Okay, for the respective terms. So 1, 0, 0 tx. So once when you multiply x and then y is 0, z is 0 plus 1 into tx. So that is why this 1 comes into picture because x plus tx. Okay, so x plus tx is there. So because of this, we have to have this value by 1 that is going to be here. Okay, so similarly for y, and ultimately it will be for y plus ty, so z plus ty. So that is why here we have this, instead of it is going to be a 3 by 3 matrix, it will be a 4 by 4 matrix. Okay. Okay, so rotation. So coming about the point of rotation in 3D environment, there are three things that we can rotate with respect to. Okay, what are those three things? It can be rotated along a reference plane. Sorry, there any axis as a reference. Okay, as a reference, we need one axis to be rotated about. So if we have, say, for example, okay, if we have an axis over here, okay, and let me say I have one line to be drawn and I want a circle to be drawn. So this is the axis. Okay, so this is the axis. Okay, this is the axis. So I want this radius r of the line to be rotated about its axis. So we have to mention along what is this x-axis or y-axis or what is this axis. So we should have one axis for reference. Any line which is parallel to any axis, okay, it can be any line of the object, but it may be parallel to the any of the axis, x-axis, y-axis, or z-axis. So that is possible in any of the drawings. So we can have that as the selection line, or there may be a situation where there is none of the lines that is present in the object is not parallel to any of the axis, but still we must be able to rotate. So there are these three conditions, but which along which it is the rotation can be performed. So let us see rotation about z-axis over here. So yes, so what is going to happen over here? So we have x-axis, y-axis, z-axis. So we have any point over here, okay, and this has to be rotated about its z-axis. It has to be rotated along this axis. So it has to be rotated like this, okay, right? So what is going to come into picture is going to be the change in its x and y values, but nothing in with respect to z, okay, because that is the center of rotation, right? That is the center of rotation in which it has to start rotating. So x dash will be same as what we had seen in the 2D transformation, x cos theta minus y sin theta, and y dash will be x sin theta plus y cos theta, but z dash new value will be same as z only, because that is the center, that is the axis of rotation, right? So there will be no change with the z value. So now once when we write these three in matrix form, x dash, y dash, z dash, and 1 will be equal to x, y, z, and 1, okay, and in the next matrix multiplied by cos theta minus sin theta, and the next two will be 0 because there is nothing else over here, it is only 0 and 0, so it is to be multiplied by 0 over here, okay. So there is nothing with respect to z over here, there is nothing with respect to the 1 that has to be unity value that has to be carried out, okay. So that is why we have 0 over here, okay. And the next one for y dash, it will be sin theta, because we have x sin theta, so x sin theta plus y cos theta. Then the remaining two terms, x and unit value 1 will be 0. And finally for z dash will be only by z itself. So 0, x value 0, y value should be 0, z value should be multiplied by 1 only, and 1 unit value should become 0. And ultimately the unit matrix 0, 0, and 1. So this we can represent it by P dash is equal to P into rotation in Z axis for an angle given theta, because this what angle we are rotating about, okay, for what angle. We can rotate it about 45 degrees, 50 degrees, 70, 80, 90, or even 360 degrees, right? Okay, so that theta is what is to be calculated. Yes. So now let us see about uh, similarly, we'll take up one more example, rotation about x-axis. So how does it going to happen with respect to x-axis? So if you are going to rotate with respect to x-axis, what is going to happen? X value will not change even after rotation. Y value will change, whereas y dash will be equal to y cos theta minus z sin theta, because it is just simple to remember. So if you remember the 2D transformations rotation, okay, what we have generally is the x dash value will be x cos theta minus y sin theta. So the starting line after x, let us go in sequential form, x, y, and z. So x is the beginning one, okay, for the rotation. So x cos theta minus y sin theta, and next one will be what? Y dash will be equal to x sin theta plus y cos theta, right? So now here it is only going to be shifted, instead of x, it is going to be rotated with respect to x axis, not with respect to z axis over here. Sorry, 1 minute, not that. It's here. Yes, it is going to be rotated with respect to the x axis. So, okay, so x value will not change. Then sequentially going now, what is the next coordinate or the axis? that is the y-axis, there will be a change in the y coordinates. So y cos theta minus z sin theta. So if we compare these both, okay, I'll just minimize this. So looking over here, we have this. First one will be cos theta minus sin theta. So cos theta minus sin theta for the beginning coordinates, where it is going to start changing. So since it is y dash, y cos theta, and then z sin theta over here. Then the next one over here is x sin theta, y cos theta. So the after y-axis, there's a change in the z value. So z dash will be equal to y sin theta plus z cos theta. So looking back over here, it's going to be the similar one except these changes. So rewriting this matrix, these four terms will get suitably displaced over here so that these equations are obtained. Okay, right? So that is how it happens. Similarly, with respect to the third axis also over here, the equations are same. Okay, only there will be a change in this cos theta and sin theta to